Hello everybody and welcome to section 3.6. Today we're going to go ahead and find the derivatives of logarithmic functions. So today is day one. So we're just going to find the derivatives of logs. So we're going to figure out how to find the derivative of things like log base a of x. What does that equal? And we're also going to figure out the derivative of ln of x. Okay. And we're going to do that by revisiting some of our properties of logs and the derivatives of exponentials. Because remember, logs and exponential functions undo each other. So the next few steps are going to lead us to that. So the first thing is to find the derivative of 2 to the x. Well, our derivative of a to the x is a to the x ln of a. Okay. So a is really like our 2. So our derivative is 2 to the x ln of 2. Okay. So we're going to use this idea to help us find the derivative eventually of log base a of x. Okay. Another piece of information we're going to need to do is know how to write a log in exponential form. Okay. So the way you guys get this out of out of log form is to go ahead. It's going to be a to the y is equal to what is left here, x. Okay. So that's how you go from log form to exponential form. So we're going to use that idea to kind of help us out. Okay. And a is a constant. A is a number. Okay, so just something to keep in mind as we go along. So it says find the derivative of y equals log base a of x. Okay, well, I don't know the derivative of log base a of x. However, I do know the derivative of things like a to the y. Okay, I can use this idea here. So what I'm going to first do is write it in exponential form. Exponential. So I'm going from here to exponential form. So it'd be a to the y is equal to x. Okay. And now I'm going to take the derivative. Okay. And one thing I would notice is I have a to the y is equal to x. So this is an implicit formula. I don't have y equal, so it's implicit. So I'm going to use implicit differentiation. Implicit differentiation. All right, so I'm going to take the derivative of a to the y. So a is some number, so it'd be a to the y ln of a. Now here's the thing. It's implicit, and I took the derivative of a y, so every time you do that, you must write dy dx. Okay, so we have a to the y ln of a equals dy dx. And now we take the derivative of x, which will be 1. And now, as you guys know, with your implicit, our goal is to go ahead and get dy dx by itself, so let's get dy dx by itself. So I have dy dx equals 1 over a to the y ln of a. Okay. And now from here, I'm going to do a little bit of simplifying because it'd be nice to have my derivative of log base a of x to only have x's in it and no y's. Do you guys see a to the y right here? What is a to the y equal to? It is equal to x. So I'm actually going to sub it in. Instead of writing a to the y, I'm going to write x. So let me get back to my pen here. My derivative, dy dx, is equal to 1 over x ln of a. Okay. So that would be the derivative of log base a of x. So derivative of log base a of x using implicit, okay, it's 1 over x ln of a. Okay. So on our next little slide here, we have that. So what is the derivative of log base a of x? It is 1 over x ln of a. Okay. So this proof shows you where it came from. This is a proof of how you'd find the derivative of log base a. Now that I showed you guys where it came from, you can just use this rule. Okay. You can also, I would recommend memorizing it, okay, because you'll want to have it for your test going forward. Okay. And then, so this is this one. So let's maybe just quickly look at an example. So if I asked you guys to find the derivative of log base 3 of x, the derivative would equal 1 over x is x ln of 3. Good. Then that also puts us as, how do you find the derivative ln of x? Okay, well, if we put a natural number e in for the base of a, okay, what happens to the derivative? So let's do this. So the derivative of ln of x is really equal to the derivative of log base e of x. Okay, ln of x is log base e of x. They are equivalent to each other. And so let's take the derivative of this. So it'd be 1 over x, and then it's ln of my base, which in this case is e. And now you guys know ln and e, they cancel each other out. And so it's 1. So I'd have 1 over x. So our derivative of ln of x is 1 over x. Okay, so you guys kind of like that one. Okay, so those are our derivatives of our log functions. So we're going to go ahead and use those derivative rules, or laws, I should say, in order to find our next, go through our next set of examples.